So the good news is for this unit, we only have 4 words to take care of. Usually your vocab sheet is like front and back and all sorts of things to memorize. Here, you're going to be memorizing rules and not as many words. So let's take a look at each of the words that we are going to cover this unit. So you've got your notes page out that looks like a grid, and in the first box, I want you to write translation. Another word for translation is slide. And my computer's going to be slow again. There we go. So a translation is a slide of all points in one figure, sliding them to a new location. Next word on your vocab sheet is reflection. Reflection, like looking in a mirror, a flip of the figure. Reflection. Next word is rotation, also called a turn. And the last word that I want you to write down is dilation, which is, of course, a resize. And we studied dilations the entire similarity unit when we talked about scale factor, when we talked about enlargements and reductions. We were doing dilations the whole time. So a dilation connects to our similarity unit. Remember that symbol was similar. Okay, let's look at some kind of boring technical terms real quick. So you're going to hear me say these words throughout the unit, and you'll say them too. So your original figure is called the pre-image. That's what you start with. When you transform it, the resulting figure is called the image. So pre-image to image. We use the word map a lot. So we say that this figure maps to the image. So when you see an arrow, that means, hey, this figure has been transformed. This is a transformation. So when you see an arrow like that, it shows you which one was the pre-image and which one's the image. Kind of like in scale factor, remember second over first? And we needed to know which one was the first and which one was the second, right? Then another clue as to which one's the first and the second is we're going to name our original image with 3 letters if it's a triangle. And then our image, we're going to use that prime notation. So kind of like Transformers, Optimus Prime, right? So B becomes a new version of B, B prime. So we don't call it a new letter. We don't call it D. We call it the same letter, but with this notation right here. That's called a prime. So pre-image becomes image. And we use prime to show you which one is the image. All right, let's dive in to translation. You're going to fill in the blank on your notes real quick. A translation is a transformation in which all the points of a figure move the same distance and the same direction. Okay, so when we translate something, we can describe it with a rule. And I don't want you to write this rule anywhere because we're going to talk about how to write a rule in a minute. But you're going to be adding or subtracting something to the x's and adding or subtracting something to the y. What's important to know is that in a translation, when you translate a figure, the pre-image and the image, so like, let's say triangle ABC and triangle A prime, B prime, C prime, are what to each other? You translate, the image and the pre-image are, hate them, nice job. They are not similar, they're better than that, they're more than that, they're congruent to each other. Very good. Okay. So let's remind ourselves what a translation even looks like. How would I translate this figure 5 units right and 4 units up? How would I do that? Recommendation. Okay, so you're saying x plus 5, I could take all my x's, and I could do it numerically. I could take all my x's and add 5 to them, right? And I could take all my y's, you're saying, and add 4 to them. That was the rule we were supposed to discover by doing it. And yeah, Jessalyn said move the dots accordingly. Yeah, you could take the vertices of the figure, and you could literally just count, kind of like slope, right? So I could take B, and I could count 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, I went the wrong way. 1, 2, 3, 4. 1, 2, 3, 4, and you call your new point B prime, and then A, 1, 2, 3, 4, 1, 2, 3, 4, 5, A prime, and C, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then you would use a straight edge, which I don't have right now. You would connect your dots, and that would be your figure translated slide. So our new coordinates, you're right, you could go to your graph and look at what the new coordinates are, or you could simply do the arithmetic. -5 plus 5 will put it at 0. -7 plus 5, -2. And 2 plus 5 would get us at 7. Cool. And then add 4 to the y, 6, 1, and -1. So what the most important part of this slide is that you can take a transformation and you can summarize it with a rule. That's what I want you to walk away from this lesson being able to do. So what did I do to my x's and what did I do to my y's? And you've pretty much already said that. To my x's, to all of the x's, we did the same thing. It's not like, okay, do this to this x and this to this x. We did the same thing to all of them. X plus 5. And we did the same thing to all the y's. Y plus 4. What words in the directions gave you the clue to add 5 or to add 4? What words? Right and up. So you're saying when we travel to the right, it's positive, right? And when we travel up, it's also positive. So that's how we knew it was up. Yeah. Okay, cool. So this was the rule right here. X plus 5, y plus 4. Let's try another one. Aw, cute little frog. Okay, so hard work's already been done for you here. This frog has been translated. Find the rule for the transformation. So we want to pay attention to which one's A and which one's A prime, which one's the preimage and which one is the image. You're going to think of this more like slope, not distance. We're not trying to find the distance necessarily, not the 2D distance. We want to know what was the path taken? How did A get to A prime? What was the path taken and how far was it? And we don't need to use the screen. You don't have to count the boxes. You can use the coordinates to help you. -6, 1 became 3, -8. You need to write a rule about that. Very good. So our rule is x plus 9, y minus 9. And we learned this in the first unit that we did. So, okay, blame it on someone else. So it's kind of like saying, hey, we traveled from -6 to 3. What is the distance, the 1D distance, the number line distance from -6 to 3? That's all you're finding out. How far apart are -6 and 3? You're looking at the x's only, and then you're looking at the y's only. And I taught you to find distance on a number line. You always subtract. It works every time. Subtract all the time, every time, subtract them. So -6 minus 3 gets us -9, and I taught you to always make the result, it's called absolute value, make it positive. It's a bad graph? What do you mean? So there we go. The distance between the x's is 9. We went to the right, so plus 9. So you do the same thing with the y. So I've got 1, -8. I told you to subtract them every time, all the time. 1 minus -8 gets us 9. And we know we're going down. So we need to do y minus 9. All right, let's practice writing the rule. We went 3 to the right and 4 down. What is the rule? Very nice. So the rule becomes x plus 3. How did we know it was plus? Because we're going to the right. And y minus 4 because of this word right here. Okay, let's see who's first. So did I trick anybody? I didn't trick Jessalyn. So I put the y one first and the x one second. So be careful about that. Left and right only control the x. So we're going to do x minus 6 because we're going backwards. We're going to the left. And we're going to do y plus 8. So don't pay attention. It's not always going to be in x, y order. Okay, now to your notes. Now let's summarize what all these rules are. Okay, so on your notes, it says, what's the rule for moving to the right? What gets affected when we move to the right? There you go, Hatham. Perfect. How do you know? X plus the constant, comma, we don't do anything to y when we move to the right. X plus a, comma, y. So when we move to the right, we add something to x. Okay, left. Right, left. X minus a, comma, y. You know the drill? What does up affect? Affects y in a positive manner, right? It doesn't do anything to x at all. There we go. And down. No. The remaining rule. X, comma, y minus a. So that's what you're writing on your notes page. You do not have to memorize these because it is common sense. You already knew how to do this before we even wrote the rules down. But that makes our notes page pretty to not have any holes, right? Okay. Let's try a few more translations, and then we will move on to reflections. Okay, in the chat, go ahead and describe this one in words. What's the next one? Very nice. Right 3, up 1. We don't need to do any more of these. We totally got it. Not necessary to do the other examples. Ooh, what about these? So I'm telling you this point has been translated, not reflected, not rotated, translated. What was the rule for the translation? How are you so fast? Oh my goodness, good job. Okay, so let's look at what happens to the x's. The x's, x plus 3, it says to describe it in words. So we're going to write 3. And then we look at what happened to the y's, and we need to be careful. From -2 to 7, the distance is 5, but we're going backwards, so we're going down. Good job. Try another one of those. Yep, very good. So what happens to the x's? We traveled from -1 to 8. So we traveled in the positive direction, and we traveled not 8, but one more than that. We traveled 9. You gave up mathing instead of verbs. And then we went in the positive direction again. So we're going to go up, and we went up 3. Reflections. Look in your notes where it says reflections and fill in those blanks. A reflection or a flip is a transformation across a line called the line of reflection. There's no such thing as a point of reflection. It has to be a full line. Each point and its image are the same distance from the line of reflection. What's that called when points are the same distance from a line? Another word for that, fancier word. Very good. Equidistant is a wonderful word for that. Okay, so what line in this picture, what line are all of the points from the image equidistant as all of the points in the pre-image? Good. The y-axis is the name of the line. Can you write the equation of that line? The equation of the line of reflection, because we'll ask you to do that a lot. Not the rule. There you go. Okay, there you go. Yes, the equation of the the y-axis is x equals 0. Very nice. So we're doing a flip. And we know that we're flipping over a line and that all of the points and their corresponding points will be equidistant. Cool. Here we go. Let's talk about strategy-wise what we would do. All right, we're told we need to flip this triangle and we need to flip it over the x-axis. So how might we go about that? What would our strategy be? Count. I love it. Let's start elementary here. Count. What do I count? Count how far away the points are from the line of reflection, the x-axis. Very good. I'm going to do the easiest one first. C is 1 away. So I'm going to go 1 away in the opposite direction. I'm going to call it C prime. C is 1, 2, 3, 4 away. 1, 2, 3, 4. Call it C B prime. A is 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5. A prime, we have reflected our triangle. And now we need to put our data in. Or put the graph upside down. That doesn't really work. Unless you had patty paper, that would work, right? Okay, so now let's enter in our data. What are the coordinates of A? C, over 5, down 5. What are the coordinates of B? Over 1, down 4. And the coordinates of C, over 4, down 1. So take a look at the coordinates of the pre-image and compare them to the coordinates of the image. Nice. Okay, let's compare the x's first because this is how we're going to write our rule. And remember, writing the rule is the most important part of the whole lesson. Okay, let's compare our x's first. What happened here? What happened? Nothing happened, right? Nothing at all. So if we were writing a rule, x, y becomes, so far, x becomes x. Okay, what happens to the y? 5, negative 5. 4, negative 4. 1, negative 1. Yes, very good. So there's our rule for reflecting over the x-axis, right? That's our rule. Okay, so we're going to skip this example and we're going to write the rules down in our notes. So go to the rule column, go to reflection, and write the rule for each one. Here's our y-axis. The rule is negative xy. X-axis, x negative y. The line y equals x. Do you know what that line looks like? Yx and y equals negative x. Whew, there's lots of negatives in these rules. No numbers. No plus a minus a times a, no numbers. Simply taking the original coordinates and either switching them or making one of them negative. So write those down and we'll talk about kind of how to memorize those. Yes, the last two, yeah, we'll talk about that. Let's talk about them first. Okay, when you're flipping over the y-axis, what changes? The x. When you're flipping over the x-axis, what changes? The y. So it's like the opposite one becomes opposite. Because that's what that means when you put a negative in front, it's the opposite. All right, when you reflect over the line y equals x, which by the way is the parent function for linear, looks like that. I call it pulling a Freaky Friday. They trade places. xy becomes yx. So they simply trade positions. You don't change the sign of either one of them. If they're negative, you keep them negative. If they're positive, you keep them positive. And then reflecting over the line y equals negative x, which looks the same, pretend that went through the origin perfectly, you're going to have them trade places and negate both of them. So a lot going on there. Over time, you will need to memorize these, but not like for tomorrow. Will we be reflecting over other lines? Of course we will. Yes. So glad you asked. Okay, so how might one go about this? Reflect this rectangle over the line y equals x. So let's use our brand new rule. Dust it off. What do? We go to our notes and we know xy becomes yx. So yeah, we just take the coordinates we are given and we pull a Freaky Friday. We trade places. 7, negative 7. I need to get a more relevant analogy. Okay. That looks like a negative 4, but it's just a 4. Okay, so now we can plot it just to give us an idea of what that new rectangle is going to look like. So 1, 2, 3, 4, 5, 6, 7. So, oh, we don't even have labels, so I don't have to label it. That's awesome news. 7, 2, 4, 2. So although it looks a little stretched out because of the kind of distortion of the coordinate plane, that is a reflection over the line y equals x. So this figure became that figure. I know, it kind of looks weird. I think my coordinate plane is not symmetrical. Okay. Name the line of reflection for the star. So this is not going to be one of your basic ones. So when we try to look for the line of reflection, we're looking for that one line that is equidistant from our pre-image and our image. And so I'm going to be nice to you and make it whole numbers. Every now and then it might be like a 0.5. But what you want to identify if you're having trouble is identify a point from the pre-image and then just find the corresponding point from the image. What point does that one go with? Oh, found it. And then you just kind of literally meet in the middle. And sometimes you'll have to count more than one to get there. So the name of this line is actually y equals -2. I know I said good job when you said -1, but it's hard to see from there. So this line hits the y-axis, so it's a y equals line, and we traveled down 2 to get there. So y equals -2 is the name of the line of reflection. Haytham, you may assume the shapes are congruent because look at your definition of reflection. By definition, if it is a true reflection, the image has to be congruent to the pre-image if it's a true reflection. Okay? So if they're asking you for the line of reflection, that means it's already a for sure reflection. Okay? Y equals 4. Let's see. What line is equidistant? Right there. Cool. 1, 2, 3, 4. It's hitting the x-axis, so it's an x equals line. Cool. They all like to brag about me. Got it first. Okay, this is one of the last things we're doing. Take a look at those transformations. Whoa. All the same number, 8 and 13. But there's negatives all over the place. So what we need to do is sort through this and find out. I would look at them one at a time. What happened in A? And then look at your rules and find out what kind of reflection it was. What happened in B? And what kind of reflection did that make it? Okay, so let's take inventory. What happened in A? Compare the x's. Ooh, nothing happened to the x's. So just write x. What happened to the y? Ooh, the y changed sign. So you go to your sheet and you look at which rule has x, negative y. You're going to memorize these eventually. Yes. So that is a reflection over the x-axis, right? I'm not talking to myself. All right, let's do the next one, guys. What happened to the x? Oh, my goodness. Whoa. Not the same. Okay, I see what happened here. They traded places. None of the signs changed. So the rule is simply that they traded places. We look at our notes. Oh, that's a reflection over the line y equals x. And then, of course, when they trade, oh, what happened here? No, they didn't trade places. The x is negative, and the y stays the same. So reflection over the y-axis. Okay, 2 more slides. Ready? The coordinates of the image 1, -2 after its reflection over the y-axis and translated to the left 9 units are ... This is called a composition of transformations. It's when you do more than one transformation in one. Okay. So we want to write the rule. Remember, that's our whole goal today is to be able to walk out of here writing the rules. So if it's reflected over the y-axis, that means change the x, right? That's reflecting over the y-axis. And then, translating to the left 9, our rule. Okay, so let's do one at a time. So reflect over the y-axis. Our new point is -1. -2. Now we want to go to the left 9, so we're going to subtract 9 from that one. So we're left with -10, -2. So it's just doing 2 transformations in a row and writing down your final step, not your middle step. Okay, good job. The coordinates of the point L to 5 after being reflected over the line y equals x and translated up 8 units. Okay, so let's do it. Let's reflect it over the line y equals x. We go look at our rule. It says to trade places, so there's step 1. And then we want to go up 8. probably is 510. Very good. Okay, we're done.